Planet Fitness is celebrating 25 years. Join now through September 13th for just 25 cents. And then,
all right. So, we've been doing some work to try to come up with a camera that can be used as a replacement for the aging PC164C EX2 cameras, which are acquiring a lot of hot pixels. And we've also been looking for a camera that can replace or to be an entry-level camera for new observers that want to come into our avocation here, our occultation astronomy at a low cost. So this is an attempt at a low-cost, high-sensitivity camera for new observers and replacement of the PC164C EX2. Okay, next slide. So here's the camera. Probably some of you are already familiar with it. I've put out some announcements on the IOTA Occultations site. It comes with a lens. It's a 140-degree f2 lens. It's actually a very nice lens. It could be used for meteor videos and meteor photography if you wanted to do time-lapse stuff. It'd be very nice for that. It's an inch, one divided by 1.8 inch black and white CMOS sensor. So the sensor is really huge. They don't even use all of the sensor for what we put out on the TV video that we get. Their actual horizontal resolution is 800 TV lines, and so they're actually they have to dumb it down actually to give us the normal number of scan lines that we have in a NTSC or PAL video. The video output is in composite video blanking and sync format. And it can be in either NTSC or PAL. That's switchable with an on-screen display menu. The on-screen display is set with a nice little dongle that's provided, and that's in the picture there. It's just got a one button, like a joystick type dongle button, and it really is easy to use and works well. It comes with 3 integrated shutter settings, and they work either in NTSC or PAL, and each shutter speed is in fields. So you'll get 2 fields integrated at NS1, 4 fields at NS2, and 8 fields at NS3 for NTSC. And then the same for PAL. So one little handy trick with this camera is if you wanted a little extra sensitivity, you just switch it to PAL, and if you have a PAL recording device like the SVID2 USB 23 type device, which we can handle NTSC or PAL, you just switch it to PAL. And now you get 8/50ths of a second of integration time, so you get a little bit more integration time. It's a very sensitive camera. It's listed here as at 0.000005 lux. That is because of the integration that is provided. And it is, in fact, the base sensitivity is at least equal to the Wattec 910HX, which I think is probably the best camera that we have available. It only is in black and white. I think Ted mentioned the other day that it has, you can input power from 5 to 17 volts DC, which is very handy. The case is a magnesium alloy. It looks plastic. Bob Anderson first thought it was plastic, and he tested it with an ohm meter and couldn't get anything to flow through it, so he thought it was plastic, but then he scraped off the paint and found out that, yeah, it conducts electricity. So it's a metal magnesium alloy. It's very lightweight. You can use it on the front end of a Dobson telescope, and the scope wouldn't hardly know it was there. Next slide. So these are two of the main menus. The menus are very simple. All of the changes are done with the image setting. You can change the video standard, but for those of us that are always going to work in one video, you would change either to NTSC or PAL and just leave that. Same way with English. And you can save your settings. So once you set everything up the way you want, you can just do a save and exit, and those settings will be saved for the time when you come back. And then the right image shows all the various image settings. You have 9 gain settings. You have 3 night shutter settings, 1 through 3. You can have wide dynamic range on or off. We recommend off for better linearity. Image enhancement. I haven't detected anything that works there, so they typically are set off. Mirror image, if you are working with a Dobson instead of a Smith-Cassegrain, you can set up the mirror image settings so that you can get your image on your screen to match your star charts or vice versa. You have brightness settings from 8 to 248. I'll show you what that does in a bit. And we even have a zoom setting, which I'll show you that too. Next slide. So it has actually a very nice display of stars. So the left side is a star chart from C2A of the same field that I have on the right. And I see my captions aren't showing up, but the star chart on the left, you can see the faintest little stars are at 14th magnitude. And on the right, by just checking stars against the star charts, I was able to get stars down below, I think, 14.2, just barely detectable. Now, the image on the right is, it's a little unfair because it's a stacked image in Registax, but if you can see a star in a stacked image on Registax, then that star is detectable if you put an aperture on it and run it in iMovie. And we've salvaged some occultations that way. You couldn't actually see the star on screen, but you run it and you get some slight light from it, and then when the occultation occurs, you get no light, and you can actually get that occultation. So it's probably good down to 13.5 magnitude, at least with my equipment, which is a 12-inch Smith-Cassegrain. The other thing I wanted to point out is that all of those are stars. There are no hot pixels. And so far in all of the videos I've seen returned from all of the current Night Eagle Astro editions that are in use that have been reported to me, there are no hot pixels, which is a really nice feature. Now, there is a little bit of a rastering of horizontal lines. And that's because we have interlocking fields, and we're using more than one set of scan lines per field scan line. And then there's a tiny little bit of amp glow as you move from left to right, but not bad. And that's why the image looks like it does. The other thing is, I actually took this image with an almost full moon about 12 degrees away. So you can see a little haloing in the background. It's a little darker in the left-hand corner. So this is all done with actually a fairly bright moon nearby. Next slide. Okay, so this is just to show you the zoom characteristic. You can go from 0 to a 5-step zoom. So if you look at my watch in my left wrist on the left-hand side, you can see it's a watch. If you look at it on the right-hand side, you can actually tell the time. So the idea with the zoom is that you can actually use it to improve your focus and then zoom back down to get your observation. So that's a fairly handy tool, I think. What you add to zoom, it actually shows in the final video. So if you need wide field, you'd go to zoom 0, but if you need to see the focus, then you could zoom up to 5. Next slide. And these two are just to show you the effect of the brightness adjustment. So both of these are at max gain of 9, and with the full moon, or nearly full moon nearby, I was going to test this to see if I could do an occultation, a lunar occultation. You can see that it kind of blows out the moon, and that's at the brightness of 250. If I set that to the minimum of 8, you can actually see the craters and some detail on the moon. I've actually done some nice collages of the lunar landscape on this camera. And I did that for the RunCam web page for the camera. So you use gain to show faint things, and you use brightness to suppress bright things. The gain and brightness can work together, but for occultations, you'd always want to have the gain at max and the brightness at max. But if you're going to do a lunar occultation, you could adjust your top level brightness so that you're not getting the glow that I'm showing on the left side. Next slide. The camera has an excellent field of view. The image scale is a little bit less than the Wattex 910HX. I did some comparative studies on my 12-inch Schmidt-Cassegrain, and you can see the plate scale between the stars that I captured with the Wattex and then the RunCam Night Eagle compared to the PC164 EX2, and I also had a RunCam Owl Plus there. And the RunCam Night Eagle Astro is just a little less field of view than the Wattex 910HX. So it's almost equivalent to a 1/2-inch chip that the Wattex has. Next slide. So this is a table of what you might be able to see as a limiting magnitude with different telescope apertures. And it's assuming that you're operating at an f3.3 focal ratio, and I'm comparing to work that I did with the original Night Eagle, which did not have the integrating capability. So I'm showing that with a 12-inch, you should be able to get down to about 14.5 as a limiting magnitude. 10-inch, 14.1, 8-inch, 13.6, 6-inch, 13, 4-inch, 12, and 2-inch, like our little Mighty Minis, 10.7. So it wasn't too long ago that the best I could do with the best camera that I had when I first started working with IOTA was around 10.7 with my 12-inch. So this is how far we've come. And this camera is about half the price as the camera that I had when I was getting down to 10.7. So we've improved. We couldn't get them to go any deeper with integration when we were working with the company to do the programming. So what we've got is what we've got. Next slide. So this is the issue about linearity that I wanted to discuss. These are 3 separate light curves, and it's the same light curve taken by ArtStar, which is Bob Anderson's desktop artificial star generating equipment. And he can drive an LED at a precise linear ramp. So the light that comes from that LED target star is precisely linear. And he actually has 2 targets. One is a star, and then the other is a bar, or an extended surface area light. And so the gold light curve here is the bar, and the blue light curve is the star. But you can see on the left-hand side that both have a pronounced curve to them, and that is a classic 0.45 gamma power curve for the linearity. What we tried was different correction algorithms using iMovie. So the next one over is a 0.50 reverse gamma correction, then a 0.45 reverse gamma correction, and then a 0.40. And this particular graphic is a compromise, but by examining the graphics and the output at higher resolution and more magnification, when you get down to the zero end, the 0.45 has very little bend to it, whereas the 0.40 has a lot. The top part looks pretty linear. And the 0.50 you can see has a little positive curvature to it. So we've discovered that you can get a nice linear output light curve at the 0.45 reverse gamma correction in iMovie. Next slide. Okay, so whatever happened to my presentation has blotted out that slide. So, Ted, I don't know what's on that slide. You can probably see it there locally. Let me see. I'm going to vamp here a little bit. I'm going to cheat and pull up my PowerPoint and see what it is that's supposed to be on this slide. Okay, so we'll look at the RunCam Night Eagle presentation. Okay, so the text is white, so obviously it got bleached out. And so what I'm discussing in this slide that you can't see is that there are some other factors that I want to report to you on. And the first one is field phasing. So the stock RunCam Night Eagle Astro Edition does not synchronize the fields to the start of a frame time. Where we were working with Chinese folks, and they were just trying to make a camera that worked on drones, and they didn't care where the fields fell. And of course, for us, we'd like to have the fields grouped together in the frames. So we never know where the fields are going to fall. They might group into the same frame, they might not. And
all right,
huge
hit.
When you start the camera and how everything works out. So the handy way to fix that is that you analyze the CSV file, or the video, in iMovie in the field mode, and then you take that CSV file and you recombine all of the adjacent fields that compose a frame into frame data points. Then you can go ahead and analyze the rest of the light curve normally, and you can do subframe timing, and all of that's been verified by Bob Anderson. So you don't have to do it if you don't want high timing and accuracy. If you just want plus or minus 1 frame time accuracy, you don't have to do it. But if you want the highest possible accuracy, including subframe timing, then you would use that technique. Another factor that I mentioned is that the camera has such a high sensitivity chip that it can see the tiniest little light leaks. And even though we're using the camera in the dark, sometimes flashlights are used around the back of the camera, and they might affect critical observations at the wrong time. So we recommend sealing the back of the camera and wiring areas with an opaque tape, such as a metal insulation tape, and that should show on the next slide. All right, so I just used metal heat duct tape, and you just run a little strip around the edge because the back of the camera just has a tiny little edge to it, and the light can leak in there. And then the sides of the camera have holes in them for the mounting bracket. And the first time I used the camera, I didn't think I needed a mounting bracket, so I didn't plug the holes. But I didn't realize that the holes were light leaks into the back of the camera. So if you just attach the mounting brackets, you automatically plug those holes. And then the mounting bracket is used as a handy strain relief for the cabling. And once you get the cabling attached, then you put a little more tape around the cable harness there, and you're really good to go. And when you're done, you just test it with a laser pointer. Either red or green laser will work. And if you don't see any flaring in the camera output when you probe around with a laser pointer, then you sealed it up just fine. Next slide. Okay, Okay, so then one final point, I think we're getting close to the end, is that all of the cameras that we use have some sort of camera delay correction in them. If they're in integrating mode, you have more correction than you do if not. And the Night Eagle Astro is the same. It has a camera delay correction that needs to be applied. But the camera has a different kind of shutter. Our classic CCD cameras expose the entire chip at one time and then read that entire chip out to a buffer and then take the next exposure. The RunCam doesn't work that way. It has a rolling shutter. So it exposes one line and reads it out and then goes to the next line and reads that out, and this rolls on down the chip. So you can get very good timing with it, and you can get subframe timing with it, but the correction has to be keyed to where the star is on the chip, because you have less camera delay correction if your star is near the top of the chip versus if it's at the bottom of the chip. So Bob Anderson has done a very thorough analysis, and he's produced equations based on the Y position of the star on the chip, which you can get easily through iMovie. When you put your aperture, you get the Y position and the X position of the aperture. And in Tangra, when you're done with your analysis, you get the X and Y positions of all the stars that put in apertures on that analysis. So either way, you can get the Y positions, you put those into a little equation, and you get your corrections. So, next slide. So the cost of the camera, it was in the $60 range through the manufacturer, but the manufacturer is no longer showing the camera in stock on their website, but they are willing to sell it to us in bulk quantities. So Ted Blank is currently receiving the bulk orders, and he's repackaging those. And I thought he might be talking about the cost in his other presentation, but I didn't hear that. So Ted, when you're all done, you might just let us know what the kit's going to cost and or what the camera will cost if they buy them directly from you through our IOTA packaging program. Next slide. So I just mentioned that, and then we references. There's several papers that are on the IOTA website. So if you go to the IOTA website and then you look up equipment, and then it goes into cameras, and you look up the RunCam Night Eagle, and then there'll be a number of papers. They're all listed here. If you are interested in the camera, I suggest that you read through these papers so that you understand the characteristics of the camera. It's a great camera. I haven't seen anything wrong with it yet. Some of the best light curves that I've received recently are through this camera because there are no hot pixels, the noise is fairly low, and the sensitivity is high. So considering that most of the light curves I see come in from Mighty Minis and Maxis and not from 12-inch telescopes, it's actually doing as well or better than what I see coming in from Malin cams. In fact, if you own a Malin cam, I'd get rid of it. I'd buy one of these and use it instead because I'm sorry, the Malicams, they're terrible. Your opinion may be different for those of you that own them, and some of you have the better, higher quality ones, but even those aren't much better than what I'm seeing with the Night Eagle Astro. Let's see. And do I have another slide? You got anything for me, Ted? Let's see here. Okay. Yeah, okay, last slide. So, I just wanted to mention that on one of the previous slides when I talked about the camera delay correction, you don't have to worry about that equation. So the new Astro report form, the Excel report form that Brad is having uploaded to Occult Watcher, automatically will correct RunCam Night Eagle numbers for the camera delay. All you have to do is put in the Y value into one of the boxes in the form, and you're good to go. And the correction will be automatically applied. And so you analyze it with PIOT or ROT or AOTA or whatever you want to do. I don't think AOTA supports the RunCam yet, so it wouldn't have any corrections to put in there. You use the form, and all the corrections will be made automatically. It's actually going to be very simple. So we hopefully have thought through all of these different details, and if you have any questions as you move forward, if you want to buy the camera, use the camera, or when you get it, have questions, I'm available. Ted's also got a lot of expertise with this camera now, Bob Anderson, and then Brad has got a lot of expertise with the form, the new XL form. So that's all I have, and with that I can answer any questions. Okay, I'm not seeing any questions, so thanks, and like I said, if you need a camera, I think this is it's a low-cost camera. It's a really good little camera for the price. Yeah, one question somebody said. Recommended settings. Well, I think there's already a document out there with recommended settings. So one of the papers there, Night Eagle Astro test report, comparison. And go to that website on the IOTA webpage, because I did put out a paper with recommended settings for the Night Eagle. And the only change with the Astro is that now we have the night shutter edition, which allows us to increase the integration. So we've already produced at least one document with recommended settings. Yes, there are other cameras using rolling shutters. For example, the QHY camera, I think, has a rolling shutter. Any CMOS camera typically has a rolling shutter. CMOS seems to be the direction for the future. It's a very sensitive. Yeah, I know I think the QHY has a global shutter built into it, but I think it's actually a rolling shutter camera with a global shutter programming in it. Bob Anderson's testing it right now, so when we get that back from him, we'll know.